Please remain muted during the presentation, and we'll direct you to unmute when it's time for our question and answer session. Thank you. Judy and Carolyn.
Okay. Good afternoon, everybody, and thanks for joining us for this last class on climate change. What are the implications for Floridians? And today, Chris Martinez is going to talk about water resources and what effect the climate change and global warming will have on that. But before I turn it over to Carolyn to introduce Chris, I want to say thank you to Chris and all of the other speakers for their presentations this semester. They have hung in for a year on this because this was the program that was supposed to have been offered a year ago this time. And they were willing to come back and do it again and do it in this manner as opposed to a live presentation. And I really appreciate that.
Have pretty long records of data, and they're considered to be fairly high quality gauges. However, one thing to note is that a lot of these gauges are airport gauges. So they were never really meant to monitor climate exactly. And I'll touch on that in a little bit. But in terms of what we see in rainfall, since 1895, we've seen very little change. 5 mm reduction in October rain of 5 millimeters per decade since 1895, which is very, very small amounts. May rain 15 millimeters per decade since 1970. But to attribute that to climate change is probably not appropriate, because 1970 to now, that's still a relatively short period to attribute it to climate. It could just be natural variability. Just had a lot of maize that just happened to be unusually dry over that period of time. But overall, we see no real change in rainfall, in annual rain, since 1895. Temperature is a little different story. So here's just a couple of examples showing summer rain, June, July, August on the upper right, where we see an increase in temperatures and temperature of most of the gauges of 2 degrees Celsius per decade. Same thing with June, July, August, 1970 to present. So that length of record, 1895 to present, yeah, it's potentially a climate signal. But one thing I would also point out, sometimes you hear that folks say, well, the South isn't warming, South isn't warming. Well, it depends on where in the South you are. Florida has been warming, and this has gone through peer review back in 2012 and was accepted. Most significant increases have been in the summer months. What else was I going to say? But one thing I would also point out that 0.2 of a degree Celsius per decade is pretty small for a length of record over 100 years. So this is nowhere close to what other parts of the country and other parts of the world have seen in terms of warming. So while Florida is warming, it's warming a lot slower than pretty much everywhere else. So that's the good news. And in terms of how this affects hydrology and water resources is evapotranspiration. So besides rainfall, the amount of water that's either evaporated or transpired is the second most important part of the water balance. But it's important to note that we only looked at temperature, and evapotranspiration depends on more than that. So particularly solar radiation. So for example, over that period of time, if we actually had an increase in cloudiness, that could cancel out the effect of increased temperature on evaporation. Same thing with relative humidity. If it tended to get more humid over time, even as temperature increased, that would reduce evaporation. So this is still incomplete in terms of the effect of this increase on temperature on water resources. Unfortunately, we don't have solar radiation and humidity data that goes back that far. We don't have that data that goes back to 1895. It can be estimated in various ways, but it gets a little uncertain. One thing we also looked at, so I mentioned that some of these gauges are not in ideal locations for monitoring climate. Because they were put in, some back in 1895, folks weren't even thinking about that then. So we did two things. We looked at how the trends are affected by the land use within, I forget how far, 10, 20 kilometers around each gauge. So that's the lower left figure, that's the land use, the black dots are where the gauges are. And then we also looked at the gauges in terms of their how good their sighting was in their particular location. And what they mean is that sometimes you hear about the gauges that NOAA uses being located right next to a building or right next to a parking lot, which, as you can imagine, as the sun heats up a black parking lot, the air temperature increases, you can get false readings. So in the upper right figure, we grouped them into what we consider good sites. that's the solid black line, and pore sites, that's the dashed line. You'll notice that there's a difference, but it doesn't negate, being in a poorly sited area does not make the trend go away over that period of time. So it's still there. And looking at the data in this way actually reinforces our conclusion that station siting issue is really not one. In terms of land use, we see only a difference in minimum temperature. So the box plot, the lower left box plot, you'll see natural agricultural areas, maybe the change in degrees Celsius per decade is about 0.15, the median value. But for urban residential areas, it's almost 0.3. And that's the urban heat island effect that you see there. But what's important is that both of those trends are still positive. They're above zero and they're significant. So Florida is warming. Again, not nearly as much as other parts of the country. Now, in terms of projections, you've maybe seen a graph like this before. That solid black line is the observed average temperature for the entire Southeast US. What's interesting is that you see the temperature actually go down maybe a little bit.
Lost the sound.
Yeah. Chris, can you hear us? Chris? Hold on, everyone. Let me see if I can get him a chat message.
He's open now, Julianne. His
No.
mic is,
He was entered by his phone audio.
oh,
He doesn't know. I sent him a message. Judy or Carolyn, can you call him? Sorry, everyone. I think he's discovered it now. Okay, everyone. He's going to sign in again. Thank you for your patience. His audio is reconnecting. We're almost there.
Julianne, I don't know if it matters, but I couldn't see his picture.
We could. Maybe you have a few minutes here to reconnect as well. I don't know. Chris, can you hear me? We can't hear you.
Okay, how about now?
Perfect. Carry on.
Okay, good. Okay, tell me which slide I was on before I went out. Was it this one or the one before?
the southeast. Right there.
Here or?
Yeah, there.
Okay, great. Okay, so again, so I mentioned that we have the warming hole in the southeast. That's a period where the temperature drops after 1950, but then it goes back up. Part of the reason that could be from burning fossil fuels, specifically coal, and then the reason why the temperature ramps back up later is better pollution control and coal burning power plants. Whether that's the reason, there's some other theories, but anyway, over the entire southeast, we did have a period where we cooled for a period, but the temperature is going back up, and the future projections are going up as well, as one would expect. So in terms of number of days over 95, we're expecting to see an increase, and I'm showing from 2041 to 2070, so that average number. Now, where this is also very important, so this is important for other reasons, heat stress, things like that, people who have to work outside, but where this is particularly important in terms of water resources is that when we model demand, when we see temperatures, even daily temperatures go up about 80, 85 degrees, we see an increase of municipal water use. And we suspect that this is all outdoor water use. So no matter whether or not it rained or how much it rained, we still see an increase in water use when the temperature goes above a certain threshold. So even if it rains, so this probably isn't automatic irrigation systems, which have a rain sensor to shut them off if it's rained recently a certain amount. This is folks either operating their irrigation manually, or they're outside with the hose doing something, spraying stuff, but spraying their garden. So what's interesting is that you would think that that's a small fraction of residences, that a lot of irrigation systems are automatic, but we can still detect it when we look at water demand data from water utilities. So in terms of our projections for rainfall, this is for 2071 to 2099. And this is with rapid emission reduction. So we start reducing greenhouse gas emissions now, and we're serious about it, and we do a pretty good job. You see not a whole lot happening in Florida, maybe a little bit of increase in winter and fall, a little bit in spring, but not much. Also, the climate models don't agree. The places where the climate models are going in the same direction are where these graphs have those diagonal hash marks. So the models, so this is really just the average value. You can have some of these models that diverging quite a bit, some projecting wetter, some projecting drier, and it's just the average. It sort of cancels out and hits near zero change. This becomes a little bit different when we look at continued emission increases. So this is basically business as usual. We don't do much in terms of curbing greenhouse gas emissions. And here's what we see. So northern latitudes, quite a bit wetter. Americans Southwest and Mexico drier. Again, models tending to agree there, but we don't see a ton in Florida. Maybe a drier summer, so a drier, wet season, and a wetter fall. And fall does tend to be more of our dry season. But what's important is that the models do tend to agree here. So this is average maximum daily precipitation from 2079 to 2099 compared to 1971 to 2000. We see an increase both in terms of rapid emission reductions and continued greenhouse gas emissions, where we see an increase of annual maximum precipitation precipitation. So this isn't a surprise. You've probably heard about this, expecting more intense rainfall events. Where this is important in terms of water resource management is that now you have rain falling faster, quicker, going into stormwater systems where they might otherwise infiltrate into the ground. When those stormwater ponds fill up, they spill over, they drain into the nearest creek. So you could see more stream water or surface water flow, say streams and rivers, because that's what our stormwater systems are connected to. And at the same time, you can see a decrease in groundwater recharge because the water's coming so fast, the stormwater pond fills up, and that water has to go somewhere. So all of our stormwater ponds have that spillover where the water drains to the nearest stream or creek or river. So number of consecutive dry days under rapid emission reduction, we're pretty good, not much of a change, but definitely a change in terms of continued emission increases. And in terms of consecutive dry days, this is particularly important for outdoor water use. So whether or not you have an automatic irrigation system or not at your home, we typically, for single family residential houses, we find that outdoor water use tends to be 40 or 50% of the total water use in the home. So anyone who's gardened knows that it's not necessarily how much rainfall you get. What's important is how many days go between rainfall events. Even if you get a half inch today and a half inch 3 days from now, I don't have to water my tomatoes. They're going to be fine. But you go a whole week and they're in trouble. So if we have that increased number of dry days, that's going to translate into an increase in total water demand at the residential level. So I figured I'd put this in here just for completeness. Vulnerability to sea level rise. You've probably seen a graph like this before. This is important is simply the number of groundwater wells that are not very far from the coast. Number of water systems that have infrastructure that are not far from the coast. Mind you, in many places, particularly down near Miami and places in Southwest Florida, they've already retreated their groundwater wells. They got infiltrated with salt water decades ago because they were pumping too much water. But a rise in sea level is just going to exacerbate things. And here's the typical global annual sea level rise. What's interesting about Florida, because we're geographically stable, the Florida Peninsula is not rising or falling like other parts of the world are. So the rate of rise off the coast of Florida is pretty much tracks exactly the same as global sea level rise. So we see that gauge data and satellite data back from 1900 proxy record back to 1800. It's hard to say that sea level is not rising. And then the projections for the future out to 2100 are a little bit scary. In terms of tropical storms, a number of utilities feel that tropical storms are actually part of your usual water budget, like where you expect a certain number of tropical storms, even if they're not destructive, to bring you a good amount of rain, recharge groundwater, etc. There's no real trend seen that we can expect more storms, but there's a possibility of more category 4 and 5, those stronger storms. But just because they're stronger doesn't mean they're going to bring more rainfall than just a tropical depression might. So in terms of the impact on water resources, it's still rather uncertain in terms of any future change in tropical storms. So what are the implications for water management? There's two issues that need to be considered here. One is, what's the time scale we're looking at? What are we interested in? How many water utilities actually think 100 years out into the future? Not many. Usually it's what's happening really soon. Consider that the length of a water use permit, so a permit that a water utility gets from the water management folks, those last for 20 years. So in terms of what they need to do, that tends to be one of their planning horizons. And it's also important that it's not the trend that gets you, it's the variation around that trend. So what I'm showing here is the Eastern Tropical Pacific sea surface temperatures, that map on the lower left. In this particular case, very warm, unusually warm waters off the coast of South America, and that's El Nino Southern Oscillation. So we look at the graph on the right, that's all those orange areas. So El Nino, which affects Florida quite strongly. When we have an El Nino event, we tend to have wetter conditions during the winter. When sea surface temperatures are unusually low, we have a La Nina, and we tend to have much drier conditions. So from the water management point of view, what the concern is what if we start to get these La Nina events, these drought events that start to last longer, start to be more intense, where we start to see ones back to back more frequently than we used to. So that's something that, in terms of climate change, might be, and understanding climate science might be able to help us in terms of what do we think is going to happen 20 years from now, 40 years from now. When I talk to water utilities, that tends to be one of their greatest concerns. What happens if we get a drought event that's beyond anything that we've ever seen in the past? So, shifting gears a little bit, current freshwater demand in the state of Florida, and this is for all uses, is about 6.4 billion gallons per day. A lot of water. By 2030, so we're not talking 2100, 2030, it's expected to go up to 7.7 billion gallons per day. So this obviously says that alternative water supplies are needed, somehow where we can offset that use of fresh water using other, perhaps lower quality types of water for different uses. And a number of years ago, the Florida Senate did produce a bill that mandated that the Florida Department of Environmental Protection conduct a study in terms of how to meet future demands using reclaimed water, which we're pretty familiar with here in Florida. Florida was one of the leaders in the country. We probably have more per capita folks using reclaimed water than anywhere else in the country. Using excess stormwater, stuff we capture in stormwater ponds, use that for irrigation. And then what they refer to as excess surface water. This is essentially drawing from rivers when flows are very high, taking just a percentage of that and using that for various uses. So they wrote an entire report on this. So I just wanted to mention that, just so you know that this has been going on for quite some time. But what is interesting, and especially when I work with water utilities, is how different types of water can cost for drinking quality water. So water from the upper Floridian aquifer, which is what we drink here in Gainesville, on average is about 1/4 per 1,000 gallons of water. Now, if we start taking surface water, which is taking water out of a river, that goes up to, it multiplies, the cost is about 8 times higher. And that's because there's a lot more organic material in it, just that requires a lot more treatment. Same thing with brackish groundwater. So that's a groundwater that's much deeper than the Floridian aquifer, where it's salty, but not as salty as seawater. And then seawater, which is about 30 times as costly as using upper Floridian aquifer groundwater. So what's important here also is that, there are utilities that are using desalinated water. They are using brackish groundwater. They are using surface water, even though these types of water are significantly more expensive. And much of that is because of the environmental damage that we've done in the past in certain parts of the state where we decided that we're overdrawing groundwater. Lakes were being dewatered, wetlands being dewatered, etc. And then just for comparison to produce reclaimed water, it's somewhere, depending on what you're using it for, if it's direct reuse or aquifer storage and recovery where it's going to be reused, it's still on the order of $3 to $4 per 1,000 gallons. Okay, so here are the population projections for the state of Florida from the Bureau of Economic and Business Research. So here's a low, medium, and high projection. So going from about 20 million to potentially up to 30 million by 2045. And this is how they project that average projection to track along with water demand. So you see it's pretty much increasing at the same rate. But what's interesting to note, and this is only going out to 2030, what's interesting to note is that at this time scale, the uncertainty in the projections of population growth and how we might develop housing in the future is greater than the uncertainty in climate, at least from now until 2030. By development, what do I need? What do I mean? This is basically assuming that we're all going to be living in single family residences on a quarter or half acre lot, very large lawns, a lot of outdoor water use. As you can imagine, this would look very, very different if in the future, as we try to handle this increase in population, if it's a matter of urban infill and where our already dense areas become denser. So not a lot of yards, not a lot of outdoor water use. So it's an interesting question, in terms of the water demand in Florida. Certainly climate is a concern, but population is an even bigger concern, or at least in the near term, and definitely how we choose to develop in the future is a big concern. And here's just a breakdown of the demand by sector between 2010 and 2030. You'll see that public water supply is the only one that's really increasing. We don't see an increase in agricultural irrigation. That's because while we expect agricultural irrigation to become more intensive, by that I mean a larger percentage of the acreage will be irrigated compared to non-irrigated. However, at the same time, we're also expecting for an overall decrease in total agricultural acreage as that gets developed into urban areas. So we'll see what happens, and then other areas all staying relatively flat. So this is from the DEP annual regional water supply planning report. They also break this down by water management district. I just wanted to say this as a point of information. You can see your more urban areas, South Florida, Southwest Florida, dominated by public water supply. That's the blue bar, where more rural areas like the Suwannee River at the upper right, the majority is agricultural irrigation, but that's because it's a much more rural district. Also in these reports that the district submits to DEP is that they break down their district into separate regions. So you can see what's going on in a particular region within a water management district if you wanted to. Okay, so what are water resource managers doing to plan for climate variability and change? So one thing we've been doing, we have a working group called the Florida Water and Climate Alliance. We've been working together since 2010. This is a collaboration of water utilities, state agencies, and water management districts, research researchers at various universities, local governments. And again, we've been doing this since 2010. We've had 21 workshops, and only in this past year have we moved to webinars due to COVID. We would have had workshops, but didn't meet in person. And so if you look very closely at this photo, you'll see a guy in the background wearing a peach color shirt. And it's too bad that this picture got cropped, because I'm kind of that's me, and it's kind of a before and after picture in terms of my hairline. So it's my proof that we actually have been doing this since 2010. So anyway, in terms of the stuff that we've done in our workshops, we archive everything on our website. So if you're interested, you can see that. Also the type of research that some of us have done, the type of journal articles that we've written. We had it there as an archive for anyone who's interested. And what's interesting about this type of working group is that, usually it's the researchers, the academics, who try to push. You guys need to use climate information. You guys need to use climate information. And that's very difficult to actually do. What's interesting about this group is that it began as more of a grassroots thing, where a couple of utilities started talking to each other and say, you're doing stuff on climate? Oh, we're doing stuff on climate. We should probably talk to each other so we don't duplicate effort. Oh, and we should probably also talk about the folks at the universities to see what they can contribute. So it's very much an equal partnership. We get a great effort to not have our workshops and webinars be set up in a way where we're just talking at folks, because that doesn't work. Getting folks involved and having them contribute is really the way to sort of create this learning community. So the overall goal is to increase the relevance of climate information, specifically as it applies to the water resource managers in the state. And in terms of what our utilities need, I mentioned earlier that water utilities don't always think in terms of climate change, just because they have more immediate needs. So what's going on in the next several months or year, that tends to be most important, so the next 3 to 12 months. I mentioned that water use permits last for 20 years, so they certainly want to be able to permit that and get that right in terms of what they're expecting to see in terms of both climate, but also population growth. And only after that 20 to 50-year focus, are they really thinking more in terms of climate change. Okay, so this is from one of our first meetings. This is the notes. This is a word cloud from one of the first meetings that we had with the Florida Water and Climate Alliance, where we were doing basically a needs assessment, trying to get folks to say, what do they need? What do they want? So the size of the word and the number of times the word shows up, it reflects how often that word was used. So obviously climate was pretty big there. Projection, scenario, you see uncertainty show up in a number of places. And then there's a whole bunch of other stuff, because this was a whole day workshop, so a lot was said. So keep this in mind. Towards the end, I've got a more recent word cloud, which sort of shows what folks who have been attending our workshops and working with us for a number of years, how they look at things now. So one of the motivations of the Florida Water and Climate Alliance is this whole idea that Florida has very distinct wet and dry seasons. So the graph in the upper right, that's the average stream flow at the Peace River in Arcadia, Florida. So just like it is here in Gainesville, very, very wet summers and tend to be pretty dry winters, spring, and fall. And since we're moving away from groundwater so much, we have very, very low capacity for cheap storage. By cheap storage, what do I mean? Where you can dam a river, flood the valley upstream where it's nice and deep, you can hold a lot of water. When we talk about reservoirs, we build these concrete line things that are only 5 or 10 feet deep. That's pictured on the lower left. That's Tampa Bay Water's reservoir. So as you can imagine, they're expensive to build. They evaporate a lot because a deeper reservoir with a smaller footprint will evaporate a lot less than a shallow reservoir with a very big footprint. So utilities are using multiple sources. We have utilities that are using desalinated water, also aquifer storage and recovery. Usually that aquifer storage and recovery means that they pull water out of a river when flows are high. When it's wet, they treat the water, then they inject it underground, and then when they need it, they pull it out, treat it a second time. So just double your costs right there, and mix it with their other water sources. So a big question becomes, how do we use the right source at the right time, both to not run out of water, but also to keep things cheap, because again, surface water, desalinated water, and aquifer storage and recovery are significantly more expensive than relying on groundwater alone. So while there are environmental concerns, there are these other concerns as well that can't be ignored. So in terms of where climate comes in, can climate help inform us when should we start pulling that aquifer storage and recovery water out? Or should we wait because we know it's going to be dry and we want to save that water for later? Same thing with filling an above ground reservoir. You think of reservoirs out west, say the Colorado River, like right now, Lake Mead and Lake Powell are incredibly low. They're at like 35% capacity, but that's still like over a year's supply of water or more. Where these reservoirs that we build in Florida, it's maybe giving you 25% of your demand for the next 6 months. And that's when the reservoir is full, 100%. So while you can rely on it, it's very, it's touchy, I guess. So in terms of one current project that we're working on now, this is a big one that's funded by NASA, where we're using remotely sensed data for soil moisture, things like that, using it to develop high resolution seasonal forecasts for the state of Florida, translating those into seasonal hydrologic forecasts, for example, a stream flow forecast for the next 3, 6, 9, 12 months. See how much better we do with these regional forecasts, and hopefully use these in terms of making those source allocation choices. When should we use what source of water, how much, and when should we stop, etc. And what's one interesting part of this project, and this is something that a lot of folks have learned the hard way, is that you really need to understand the decision-making process that these utilities use, and not just ask them and they tell you. I mean, really understand it, understand it where science really does plug in. So for this project, we're working with we have a social scientist working with us, who's working with our utilities to try to better understand this process, where science plugs in, what are their barriers, et cetera, et cetera. So really what we wanted to do was not build it and they will come kind of thing, where you build a better mousetrap, then you finally show it to the person and then, they're not interested. You want to have them involved as you're building that better mousetrap from the beginning. So in terms of barriers to adopting climate information in water resources, we see pretty much the same thing we see in other parts of the country. So first, climatologists and hydrologists do not speak the same language, or at least not exactly. It takes a little while for folks to understand one another. And this was a major problem that agencies like NOAA and others made, that when they first started to issue seasonal climate forecasts, they didn't really involve end user groups in their development. They started making these in 1995, figuring, oh, everyone's going to think they're great, everyone's going to use it, especially water resources. Oh, they're going to be the early adopters, right? Well, you know how many utilities actually use these, and it's how many years since 1995? So not a lot. So there's certainly an awareness issue. There's a scale issue. So, a lot of forecasts are like the upper right, where it's, the entire country. Doesn't really seem to give you a lot of specific information in your particular location. We have folks who, even with advanced degrees, misinterpret the meaning. Perception of poor skill, that these forecasts aren't very good. Often we hear folks equate climate forecasts to weather forecasts. You can't tell me if it's going to rain two days from now. Why should I trust what you tell me is going to happen in the next month or three months? It's climate forecast is not the same thing as a weather forecast. We also see institutional conservatism. So someone who maybe wants to use a climate forecast in their projections, in their own forecasts, but they're worried that if they do use something that's rather innovative and they turn out to be wrong, that they're going to get criticized compared to just doing business as usual and staying safe. And then there's also an issue with regulatory constraints. We don't see this much in Florida, but say places where water supply is reservoirs that are run by the Corps of Engineers. The Corps of Engineers tends to have fairly strict operating rules. What level do they try to run the reservoir at? When do they release water? How much? Over what period of time? So we did this survey research. I did this with an anthropologist a number of years ago, where we surveyed folks across Alabama, Georgia, and Florida. And we basically came to the same results that folks get up in the Pacific Northwest, Pacific Southwest. So there's definitely an institutional barrier in terms of water resource folks, water resource engineers adopting climate information. Okay, so this is my last slide. I'll be happy to take questions. And on the right, here's the word cloud that we put together in 2019 after we've been working with these utilities for a number of years. You see a lot of words pop out that didn't pop out before in the first one. You see team, expertise, research, climate change, partnerships, learning. And that was pretty much our goal. I mean, this is really just a snapshot, but a lot of the folks that we work with have been working with us since the beginning. So back in 2010. So this was pretty nice to see. So I'll stop there.
Thank you very much, Chris. It's turned out that water management and water resources are a lot more complicated subject than I think we thought to begin with. We'll open it up to questions, and I'll have Julianne facilitate this if there are people in the Oak Room who have questions or in the chat. So Julianne, it's yours.
Okay. Don or Pat Collier, do you want to go ahead? I see you unmuted. Don Collier, do you have a question?
No, we didn't.
Oh, okay. I'm going to go ahead and mute you then. Richard Petway, go ahead, unmute.
Can you hear me okay?
Yes.
Okay. I guess I have a question, and I have to apologize because I have not attended every meeting of this group. So my question could have been already answered multiple times, but obviously here in our area, we're very concerned about the springs. And the latest spring issues I want to ask you about is Coca-Cola, other large major manufacturers get the water, a huge amount of our enjoyable water from the springs for free. And to me, that in a time when we're thinking about using less quality water because we're giving it away free to these large companies, doesn't appear to make a lot of sense to me. But on the other hand, I'm sure there are strong kind of positive answers associated with employment and so forth, existing capital formation and so forth. But Could you give us a kind of quick synopsis of where we are are we moving towards trying to control the amount of water that is taken for free from our springs? Or is that so far in the future, it's not to be knowledgeable? An update would be very enjoyable for me. Thank you.
That's an excellent question. I guess one thing I would say that at the very least historically we have not seen a decrease in rainfall, say in our area that are feeding our springs, recharging groundwater and everything. So that's the good side. I guess the bad side is that, you know, when you talk about using the water for free, you're talking about water rights. You know, when you tell someone that they can't use, and water law, you know, when you tell someone that they can't use that water underneath the land that they own, that they bought specifically for that reason, that's considered a taking in a court of law, to my understanding. So that can get pretty ugly pretty fast. So I'm not, so to answer your question, I'm not familiar with any efforts to really start to change Florida law in that direction, other to say that it certainly gets a lot more feedback now than it did 20 years ago. You know, a lot of folks are certainly making a lot more noise than they did 20 years ago. What that might translate to, it's hard to say. I guess someone that maybe specializes in law and policy would be able to better answer that question. But that's a very good question.
Thank you.
Thank you. Bob Bernstein, go ahead. We can't hear you.
Can you hear me now?
Yes.
Okay. Two questions. You had mentioned nutrient pollution. How accepting are these groups of limiting nutrient pollution? And that seems to be, as far as I'm concerned, almost the #1 problem in terms of water quality for springs, for estuaries, or loss of seagrass in Indian River Lagoon, where I worked. And what's the in general, what's the reluctance of local governments to incorporate climate change? I've spoken to Putnam County commissioners, and you know, the St. Johns River is tidal at Palatka up through Lake George, to say, well, the sea level rise is really important here. It wasn't an easy sell. How did you get cooperation? By involving people at the beginning?
Yeah, you know, one thing that's interesting. So we work with Tampa Bay Water, and they're basically a state agency of sorts. Their governing board is their member governments. So it's the commissioner from Pasco County, it's this person from this city. These are elected officials. They're usually not experts in water, which is understandable. But also sometimes their politics may not always align with the person who's talking to them. One thing that I will say is that in the past they've said they wouldn't use the word climate change. They would talk about being resilient. What happens if we get two large droughts back to back that we've never seen before. So they kind of dance around it, but they've also been able to get to do what they've done. So for example, they have funded research here at the University of Florida, and they have to get those folks to sign off on it. And they've done it. So yeah, we've been successful in that regard. It is fortunate that these days it's not a dirty word to use the term climate change in the state of Florida anymore, where it had been for some time. So in terms of nutrient pollution, I guess a lot of these water utilities don't directly work with nutrient pollution, but since that's sort of another hat that I wear, so if we specifically think about the springs and rivers in north central Florida, the whole best management process and the BMAP process, Basin Management Action Plan, those things have been in the works for quite some time, and you're definitely going to see a point where best management practices aren't going to be voluntary anymore. People are going to be told you have to do this. It's taken a long time, because that's obviously, as you can imagine, that's not particularly palatable to a lot of folks to have to say that. But even just thinking of, the Santa Fe River, I mean, it's heading that way. And I guess that's really just my personal opinion, because I'm not really directly involved in the whole process with the Department of Environmental Protection and the Department of Agriculture in the state. But that's the picture that I get. I mean, it's taken a long time. It's taken a lot longer than everyone wants it to, but it does seem to be heading in that direction, in my view.
Okay, there's a question in chat that says, do you think the appointment of John Kerry as the lead in the government to deal with this issue will have an impact?
That's a good question. Someone like John Kerry is certainly well known and respected. I mean, might be vilified by some, but I can't help but think that someone like him, compared to someone who, without name recognition, I would think that he would be able to do better and have a little bit more pull. But again, that's just my guess, my opinion.
Thank you. And the last hand I see is Barbara Herbstman. Go ahead.
Thank you for your presentation. I was wondering, with the collaboration of all these agencies that you mentioned, was one of them the public schools to teach the children the importance of water conservation and good water management? Is that in the equation somewhere?
Well, we haven't been doing that directly. It's what's interesting. So none of us are really all that connected to what the public schools are doing, other than some of us have done some work with 4-H kids. And I got to tell you, I can give a lecture to you guys, and I can give a lecture to a bunch of graduate students. Giving a talk to a bunch of middle schoolers scares me to death, just because I really don't know what they've been. I can go and give a talk, but I realize that they do a whole lot more in these areas of science and the environment in schools now than they did when I was a kid. So that's the closest connection that I have. I guess my only other connection is that I tend to volunteer as a judge at the state science and engineering fair for the state, so I can kind of pick up what some of these kids are being exposed to. But at the same time, when you talk to a group of 4-H kids, sometimes they're there because they're already interested in that topic. So what about the kids who aren't interested in that topic? What are they getting exposed to or not?
That's not the thrust of my question. Thrust of my question was not you or people like you directed toward going into schools and teaching. Rather, dealing with the school system to put this into the curriculum so teachers are trained and can teach even at the lowest level, starting with kindergarten and preschool, how to conserve water, from the simple thing not to let a tap run. I mean, so I'm just wondering, and I think this is part of the problem. You don't want to start getting to people at the high school and college age and talk about the importance of water. You need to start at the earlier age. But as you said, there's no need for people who aren't really trained to do that. So that's why I'm wondering if there has been any attempt to get the curriculum at the state level changed so that professional teachers can actually be trained to do the kinds of things that convey the kinds of information that you want to teach the children. That's where I'm going.
Okay. Yeah, I guess I can only say two things, and this isn't going to be a great answer. I guess the short answer is I don't really know, unfortunately. But I do know that they do a lot more than they used to, but I'm 47 years old. So what am I comparing that to? So that's a long time ago, when I was, in elementary school. I know that they do more, but whether or not it's nearly enough is certainly a very good question. And other than that, I don't know of any concerted effort from anyone to try to try to change the curriculum. You know, one thing that we have in Florida with the school system is a number of years ago, they really went to the teach to the test kind of model. It's not on the standardized test that these kids have to take. You know, my understanding anyway, which isn't very good, you know, these other topics maybe kind of fall to the wayside, because what the schools and the districts are concerned is how well they rank, how well they grade.
I think Julianne has a comment. I see her on chat.
No, I just was chatting. As a former teacher, I have seen water management, water education become part of the objectives. You know, I'm elementary, but we definitely are starting there.
And someone has noted that
also,
there is a required 5th grade science test now, and that it is in the objectives. So that is a good start to getting it as part of the curriculum. Good. Did you have another comment, Chris?
yeah, I guess I should point out, I don't have children, so this is probably another reason why I really don't have, you know, I'm not very versed in school curriculum.
I see one more question. Anne Marie, do you want to ask it, or do you want me to read your chat?
Oh, I can ask it. It's just, I'm always wondering where people get their ideas from. Funding sources are one thing, but in terms of trying to figure out where global climate change research is going, I often wonder how much either in Florida or in the United States, climate scientists look to other countries' best practices to either guide their research or ask their study questions, irrespective of whether or not it's going to get funded. I just wonder.
Yeah, I would say that there's quite a bit of collaboration internationally, for sure. You know, I guess where the big issue comes into is when it gets down to brass tacks, when it comes down to policy. You know, for example, why don't we plan for storms the way they do in the Netherlands? You know, rather than a 1 in 100 year storm, it's the 1 in what, 10,000 year storm. Yeah, how to get something like that changed is pretty much beyond me. You know, we can certainly do the research in terms of what can happen, and you know, even recent events, take Hurricane Sandy and the New York City and New Jersey coast. We saw what happened there, and they're talking about hardening the coast, but exactly how far they'll go, yeah, it doesn't seem like they're willing to go that far.
Thank you. Eli, go ahead.
The Stetson University in DeLand has had an amazing success in reducing its carbon footprint. Unfortunately, not many people know about it, and I've often wondered whether the University of Florida ever even gives a damn on the issue.
Yeah.
But they've been able to reduce their carbon footprint by at least 10% and more a year over a number of years. And it hasn't cost them money, but they've saved a significant amount of budget by doing so. Are you aware of their work?
I'm not specifically aware of their work, but I can speak a little bit in terms of what UF is doing. So we do have a faculty sustainability committee at UF. Now it's really just an advisory committee. I'm on it, and we advise the Office of Sustainability, which tends to interact with other units at the university. So I will say that they're definitely interested in doing stuff. I mean, even if they don't have much control in terms of, say, the source of their energy or things like that, or can't get large investments to go to more renewable energy, they've been doing other things in terms of reducing waste, reducing materials that are used that create more emissions. So I know they're doing that, but I'm sure they're nowhere close to 10% per year on year, I would have to say.
May I suggest that you poke the University of Stetson University, DeLand, especially a vice president for facilities management, and explore what they've done over the last several years. It's a very impressive program, and was started by somebody named Al Allen, and he's been replaced by another VP who has a history of that, and would be a worthwhile thing for the University of Florida to emulate. That's my comment.
Yeah.
Thank you.
Sure. Thank you.
Thank you all very much. Thank you, Julianne, for handling all of this. And Chris, thank you very much for your time and your really interesting program. It's given us a lot to think about, not only in connection with water resources, but as we look back in terms of all of this fitting together, all of it is very interdependent, whether it be agriculture, climate change, fisheries, power, all of those. Thank you very much, everyone. We'll look forward to seeing you at another ILR. Chris, bye-bye now.
Thank you very much.
Thank you.
Well, thank you for having me.